Hello students, today's agenda is to check homework. We'll be learning about radian to degrees and degree to radians, and you will be able to do 11.1b. Today students will be able to convert radians to degree measurement and degrees to radians. But before we do that, what is a radian? And I started drawing it in here. I was going to draw it and have it ready beforehand for you, but I think it's good if I show you how I did it. So one radian measurement is equals to 1 radius. Every circle will have 6 and a little bit more radius around it. If you have seen the circumference formula is 2 pi r. 2 times pi is about 6.28. So that's the 6.28 multiplied by the radius. That's for the circumference. So 1 radian, 2 radians, 3 radians, and so on. How did I do this? Truly what I did, and that's why I said it's not perfect, is I used one of my beautiful art. I used this one just because that's what I had at hand. And so what I did was to measure one radius about here. Okay, and I started measuring and making the little marks. And now here it is. One other thing that we need to know is that around a circle is always 360 degrees. And so if we divide by that 6.28, 360 divided by 6.28, in degrees, each of these ones will be 57.32 degrees. Okay. So now what we're going to be doing is that we're going to be converting angle measurements in degrees to radians, and sometimes they're going to give me radians, and we are going to find out what measurement would that be in degrees. To convert from degree to radians, we multiply by pi over 180. And to convert from radian to degrees, we're going to multiply by 180 degrees over pi. If you notice, these are the reciprocal of each other. We just switch pi and 180 degrees. So in here it says convert to degree measure. And so we have 3 different examples. One tip that I have for you is that if this one already has pi, it's going to be on the numerator. So what we're going to put is the pi in the denominator. Just remember, if you have pi on top, then you put it at the bottom. And for the degrees, you will not have pi, so that's going to be in the numerator. So if it's on top, put it at the bottom. If there is nothing, I'll show you one, then you put it on the top. If it's on top, you put it at the bottom. If there is no pi, you put it on top. Okay, so in here, something that we're going to do is that whenever you have the same value across, cancel pi and pi. On these ones, they can also be simplified across. The 3 is divisible by 3, and you get 1. 180 is divisible by 3, and you get 60. And now, when you cancel the pi, it's like you have a 1 and a 1 in there. So 1 times 60 is 60. And then 1 times 1 would be 1 in the denominator, but 1 in the denominator, we don't need to write it down, okay? So that will be equals to 60 degrees. For number 2, we do the same thing, times 180 over pi. Pi cancels, you get a 1 in here you don't need it. Both of these are divisible by 18. 18 divided by 18 is 1. 180 divided by 18 is 10. Then we multiply across. Negative times positive is negative. And we can actually put the negative on top, or we can put it in the middle. 7 times 10 is 70. And we don't put 1 in the denominator. We just leave it as negative 70 degrees. 180 over pi. We multiply by 180 over pi. Again, we cancel pi. Why? Because pi divided by pi is 1. In here we can divide by 5. This is 1, and then 180, 36. And then 36 times 30, right? This right here is equal to 80 degrees. For the next ones, now we're going to convert to radians. Again, this one doesn't have it. That means that you put it on top. Doesn't have what? It doesn't have pi. You put pi on top over 180. Because this doesn't have a denominator and you need to multiply straight, you're going to put it over 1. When you have zeros, both of them are divisible by 10, and it just means eliminate the 0. So in here you have 33, and then 18 over here. In here, I noticed that 3 plus 3 is 6. 6 is divisible by 3. That means that 33 is also divisible by 3. That's a rule, divisibility rules. 18 is 1 plus 8. 1 plus 8 is 9. 9 is divisible by 3. That means that 18 is divisible by 3. And that works only for the 3 and for the divisibility of 9, okay? Not for all numbers. So if I divide 33 by 3, I get 11. If I divide 18 by 3, then I get 6. And I cannot simplify anymore because this is a prime number. So now I'm able to multiply straight. And so 11 times pi is 11 pi over 1 times 6, 6. So this is my answer in radians. So 330 degrees is the same as 11 pi over 6 radians. Same for negative 700 multiplied by pi over 180 degrees. Put it over 1. Again, both are divisible by 10. So this is negative 70. And this is 18. This ends in 0, but this one doesn't end in 0. And it doesn't end in 5. But I know that this is an even number because whatever ends in 0, 2, 4, 6, 8 can be divided by 2. This is a 0 and an 8, so both of them can be divided by 2. And so negative 70 divided by 2 is negative 35, meaning half of negative 70, negative 35. Half of 18, 9. This can only be divided by 7 and 5. This can only be divided by 3, other than 1 in itself. So now we are able to just multiply straight. Negative 35 times pi is negative 35 pi over 1 times 9 is 9. And this negative, you can just leave it up there, or you can put it right in the middle of the fraction, 35 pi over 9. Either way is fine. For the last one, again, we multiply by pi over 180. Put this one over 1. So in this case, 90 degrees and 180 degrees both are divisible by 90, which is equals to 1. And 180 divided by 90 is 2. We multiply straight. 1 times pi is pi. And 1 times 2 is 2. So 90 degrees in radians is pi over 2. With this, we end our lesson. If you can please give us a thumbs up, subscribe around here. This is the link to the entire unit, and here you will find the next lesson. Now you're able to do 11.1b and have fun.